All right, hello. The next one here, 8.7, is all multiple choice with some graphs I'm giving you. Let's read the first one. The graph represents the relationship between height and time for a fireworks rocket. Which statement best describes the situation? Let's not worry about A, B, C, and D yet. Let's just talk about the graph for a second. You need to look at the very bottom. You see it's labeled time, and the S stands for seconds. Then along the other side, right here, is height, and it has an M in parentheses, so it stands for meters. So at 0, 0, which is right here at the origin basically, that's at 0 seconds, the firework was 0 feet off the ground. Well, that makes sense. But if you go to 1 second, go over 1, and go up until the graph, or till you hit the graph, and it looks like it's almost 30 feet. So like, I don't know, 27, 28 feet. I don't know exactly, but again, it's almost 30 feet. Try 2 seconds. All the way up, it's about 45 feet right in there. 3 seconds would be, looks like it's going to be about 50, 55 feet, and it keeps coming down every second. And when it hits the ground, which is over here, you see it's almost 7 seconds. Almost 7 seconds. So this firework went up and came back down in 7 seconds. Now let's read our choices. Answer A. The rocket, or the firework, landed 7 meters from where it took off. No, we don't know that. The graph does not give us that information. Letter B. The rocket took about 50 seconds to go up and come back down. No, not 50 seconds. We can tell by the chart, by the graph, it's almost 7 seconds. Answer C. The rocket trip took about 7 seconds and went up about 50 meters in the air. That sounds like it's pretty good. Let's circle that one, but let's go ahead and check D. D reads, the rocket began and ended its trip in the same location. We have no idea. That's not what the chart gives us. So my answer is C. 7 seconds, 50 meters. Let's look at number 2. Oops, I'm sorry, I did the wrong one. That's number 4 on your chart. Sorry, let's go back to number 1, and we'll start kind of work backwards here. I'm sorry, I just did number 4 with you. Answer C. Make sure you're on the right one now. I apologize. This one, the graph shows the relationship between distance and time. Well, here's time, and right here's distance. Time in seconds, distance in feet this time. Notice it says FT right there. For a ball dropped from the top of a 50-foot tall building, which statement best describes this situation? So, the ball drops. At 0 seconds, the ball is 50 feet. So it's 50 feet on top of this building. After 1 second, right here's 1, it looks like it's going to be, I don't know, almost 35 feet. Then look, when it hits the ground, right out here, it's almost 2 seconds. Almost to the 2 seconds when it hits the ground. So this ball, from 50 feet down, 2 seconds or almost 2 seconds, it hits the ground. Let's look at my choices. Answer A. It took 50 seconds for the ball to reach the ground. No, not 50 seconds. That's too much. Mark that out. The ball took less than 2 seconds to reach the ground. That could be my answer. Let's circle it, but let's not give up. Answer C. The ball landed about 2 feet from the base of the building. No, we don't know that from our graph up there. The graph illustrates the path of the ball, not the path of the ball. It's just illustrating time versus distance. So it's not D. So my answer is B. Look at number 2. This graph shows how income varied as the company tried different sandwich prices. What price maximized income? So I'm going to circle the word price. What price of the sandwich maximized their income? Well, if you look at the first one right here at 0, 0, that really means that if they charge $0 for the sandwich, in other words, they give it away for free, they would make an income of $0. Well, yeah, if you charge 0, if you give it away, you're not going to make any money. But if you go all the way to the right where it says 14, that intersection means if they charged $14 for the sandwich, they wouldn't make any money. And that is because $14 is too much money. No one would buy it. So what price of the sandwich maximized income? And it's right here in the middle. $7 sandwich, and the income would be over here at the 2000, at that intersection right there. Now, a lot of people on this problem think the answer is C, $2,000. It's wrong. The answer is A. It's the $7 because my question was what price, meaning what price of the sandwich maximized their income. And that's the 7, not the 2000. So you got to be on your toes. Pay attention. Keep your eyes open. One more. Let's look at this third one on your paper. That's our last one here because I did this in the wrong order. Last one. The graph shows the relationship between height and time for a ball dropped from a 250-foot tall building. How long did it take the ball to get halfway to the ground? Well, right here's 250 feet. And they drop it, and it looks like it took about 4 seconds for it to reach the ground. Well, the trick is halfway. Well, 250 divided by 2 is 125. So if I come over to the chart and find 125, and I go straight across to that graph, and I look straight down, about how many seconds would that be when the ball was halfway? It looks to me like it's almost 3 seconds. So my answer there is the C, almost 3 seconds. Hey, thanks for watching.